Have you ever played a Battlefield game and thought to yourself, how are those destruction effects made? This video is how. In our time together, what we will try to accomplish is recreate a wooden frame destruction effects, such as the one you see on the screen, in Houdini. And I was playing Battlefield 5 just a few days ago. I think it was a Wake Island multiplayer map, and there was a construction site. I ran into it, and I saw this piece of frame with a hole in it, and it was very curious and intriguing for me to see if I can actually recreate this effect using Houdini. So I spent a few days dabbling around and messing around with the idea, and I think I have landed on something that looks decent enough to teach you guys. So that's what we're going to do today. We will try to replicate or recreate a Battlefield style destruction effect. And this right here is the end result. Obviously, it may or may not be the exact replica of what you see here, but it should be something very, very similar. So a little housekeeping before we continue. If you like, comment, and subscribe for my channel. It helps me a lot, help you, because these sort of videos take a ton of time to put together, to record, to plan, organize. So it makes a world of difference if I see some kind of reaction from you. Am I going in the right direction? Is there a specific effect you want to see? Maybe you want better ways of explaining stuff, or maybe you want me to focus more on Vex, on code, or whatever it is really. So if you have any question or a suggestion or feedback, you're more than welcome to use the comment section below and give me an input. Tell me, how am I doing? All right, with that said, let's fire up Houdini and let's get this going. The first thing we want to do is I'm going to press U on my keyboard to get to the upmost level in a sub level. And what we want to do is hit tab on our keyboard, and that's going to pull up a basically a node menu. We want to type in a geometry, which is going to be a geometry container that we're going to work within. And while I'm here, I'm going to press pause, so it's not that distracting. We want to work here. Actually, let me repeat this. We want to work in a container because this is where all of our work lives inside at the surface operator level. And this container is going to encompass all of that information. Since I have it already created here, okay, I'm not going to go and kind of work in a new one, but you should do that. You should work in a new container. Okay, so I'm gonna get rid of this one. Press delete on my keyboard, and that's gonna get rid of that. So I'm gonna select the one I have. Press I on my keyboard, and there we have a whole network that is made to create the effect here. And I'm gonna keep it on the screen just for my own reference. If I need guidance or the logic how I thought behind the effect, I'm gonna refer to this, and it's going to help us move forward without losing much time. So what is the first thing that we need to do? Well, let's look at this reference image here. I'm gonna initiate my drawing thing here, and actually, where is it? Actually, I've lost my pen. Hang on. Oh, here it is. It's right here. Okay. So where are we at? So we know that we have a structure, right? We also know that this structure is divided into horizontal segments, and we know that is divided into vertical segments. like so. So the first thing that we need to do is we need to create this frame. Okay, so let's do that. How can we do this? Well, I propose we use a node called cube. I'm going to initiate a node network, and I'm going to type in cube. I'm going to let go of my mouse, zoom in a little bit, press down R on my keyboard, and select the node. And when I do that, a display flag pops up, and we can see the result of the node. And I'm going to press Shift W to initiate the shaded wireframe mode so we can see the wireframes there. Next, I'm going to press P on my keyboard while my mouse is hovered over the working area here. And what I want to do is I want to try to massage this plank so it looks something like the vertical beam right here. Okay, so we know that we need it tall and we need it quite thin. So I'm going to take my node, maybe take it a little bit closer to here. I'm going to press P on the keyboard to get the menu of the node once more. So let's try to replicate this. So this is going to be X, Y, and Z. So I think I'm going to start with the Y, and I'm going to give it a little bit more height. And to actually help me with height, what I can do is I can bring out Tommy geometry. Okay, there it is, Tommy. And this is going to help us gauge or size of things as we create them. So I'm going to press E on my keyboard. I'm going to select Tommy geometry. And once I do that and press W while I'm on the display here, a viewport, that's going to give me this wireframe mode so I can stay through. And here it is, I see Tommy, which is around 2.2 something units in height. So pretty realistic height. We want to base our geometry or structure that we're making in real world units. So Tommy is going to help us with that. I'm gonna select my box node, press P on my keyboard once more, and let's start with 3.5 meters in a Y, okay? But there's another problem. See, when I do that, okay, let's focus on this area here, okay? See how Tommy is sitting right on the level with the ground, which is exactly what we want. We want our structures or anything that we are creating flush with the ground at all times. So how we can take our box or our plank that we just created and move it up to the ground? Well, I propose we bring out a node which is called a match size node. Well, and I can find it by searching in the node menu here. I'm gonna press tab on my keyboard once more, type in match, and there we go. There is a match size node right here. And if I select it, and if I select it and let go and connect my box to the first input, hold down R on my keyboard so I can view this node. What I can do is I can push the y-axis to the minimum. So the logic here is very simple. I need to take the minimum of my box and I need to bring it in line with the grid or where Tommy is sitting. So let's see how we can do this. Let's double around with the settings. I'm gonna mouse over the justify y and I'm gonna say minimum. And when I do that, our box all of a sudden is flush with the ground, exactly what we need. And now what we can do, press tab on, W on my keyboard while I'm mousing over the viewport. Now I can go back to the box node and I can start reeling this geometry in a little bit. 2.4. I think the battlefield geometry is quite high. I think it's somewhere around 3.5 or 4. So let me go back to the node here, and I'm gonna start with something like 3.7. All right, so we got the height, but the width and the length is too big for a plank. So we need to reel that back in as well. For that, what we can do is we can select this unit, x-axis, and we can, like, as we select it, oops, not like that, but we can, actually, I'm gonna control middle mouse on it to bring it back to the defaults. I can select it and drop it inside here and say relative channel reference. And that's going to basically copy in a reference of this parameter. So when I want to change this, the other one is going to change with it. Let's demonstrate this. I'm gonna middle mouse over this X metric, and it's going to pop up this little like menu. I'm gonna go a unit below, so it's 1.1, takes by the 1, and you see how it kind of gives us what we need. But actually, that's not what I want to do. So I'm gonna right click here, say delete channels. I have something else planned. So I'm gonna make this a little bit thinner, something like, let's see, maybe 15. Okay, so I'm gonna say 0.15, and let's see what I want to do with this one. I want this to be a little bit deeper, so I'll say something like 20 maybe. It's still too thick, I think. So let's see, maybe 0.8, and in the width, and maybe this needs to be something like 15. So this, it's quite important to take the time to create these structures true to how they are in real world, or in this case in a game environment, because we're gonna destroy this thing, and we need it to look realistic. So the more time we take to massage in the proper units, the better it's going to look in the end. So if we compare our plank, which is the vertical plank, to the one from the battlefield, I think we're somewhere close. I think I could even take this and put it somewhere like 0.7, something like this, or maybe even 6, something like this. Okay, and I think it's still too deep, so I'm gonna say something like 12, or maybe 10. Okay, let's start here. Next thing I need to do, looking at the reference image, is now that I have created this piece, the next thing I propose we do is deal with the vertical ones, or should I say horizontal ones. And my logic would be this, actually. I want to take sort of this part, which includes this, and this. So I want to take that, and then I want to build it once, and then I can copy it over here, then here, and then over there. We don't need to rebuild this like from scratch every piece. What we can do is build one part, duplicate it over, and so that we have it like that. So with that logic in place, let's build those horizontal pieces. What we can do is either take the same box node and create it from that, or we can use the same node called cube and put in inputs however we want. But since we have most of the settings dialed in already, I'm gonna copy this node and duplicate it over. How did I do that? I selected node, pressed Ctrl C on my keyboard, moused over to the right, and pressed Ctrl V to duplicate it. And now when I put my display flag to it and pressing P on my keyboard, we have the same thing. And I'm gonna reference the previous one by pressing E on my keyboard. And now what I need to do is rotate this little beam in this direction. Okay, so let's do that. I'm gonna go and rotate this in, I think it's Z. Yep, it's gonna be Z. Let's try 90, and that's giving me much better orientation there. And you said you just saw I put my display flag from this box to match size. It's because match size is already flush with the ground, and it's going to help me better gauge where should I align it. All right. Now the problem is this newly created cube or plank is in width to width. Okay, so I want it a lot smaller. So we know that that's an X direction. So X, Y, Z. Let's try to maybe minimize this. Okay, that didn't work. So it's Y. Okay. So I want to create it just as big as this one. Okay, so let's play around with the settings until I see something that resembles that. So maybe something like this, 0.5. Maybe I'm gonna put 0.6. I think that's gonna be better. And listen, we don't have to be, crazy about this perfect setting. We can always come back and change those. So what's next? Well, the next thing we need to do, looking at our reference, is we need to set this little piece over here that we just created, and we need to make it flush to this beam right here. See how it sits evenly? Like right there? And for destruction effects, there can't be any directions, and that's why we're taking this long route. Obviously, we could create the whole thing by just one plank, duplicating it over with the intersections, but that's not going to work for us, because in destruction effects, there cannot be any intersections. So we need to work with these match size nodes here that help us align geometry one to another. All right, so I'm going to take my box, and I'm going to click on the pin, drag out, click tab on my keyboard, and I'm going to type in match size, which we're familiar already. I'm going to put my display flag to it, press P on my keyboard to get the settings menu. And now I think we need to align it over to the X axis, which we see here. The red is X, so it goes in this direction there. So that's an X direction, right? So if we're right, then we can use justify X to the minimum, and that's going to give us the result we're after. But there's another problem. It doesn't look like it sits flush with that beam. So let's see what's up with that one. Maybe we can change these settings. We can't do that with that one. Oh, maybe it's the Y, the green axis. Okay, right. We need to push it a little bit over on it up, and we know that that's a Y. See? That's a Y. So let's do that. I'm gonna try with the minimum, and we have it. But there's another problem. Now it intersects here. Well, maybe we can fix that with the Z. So let's try that. Minimum, maybe maximum. Nope. Minimum, center, maximum. Okay, that didn't work, so let's press none. Just for X. Maximum to... Oh, I think we need to do minimum. Let's see. I propose we now create a merge node. Press tab on our keyboard, type in arg merge. Okay, and what merge node allows us to do, we can take both of these boxes that we just created, and we can merge them together so we can see an output together, so we can see and display them both together. So I'm going to take the output of the match size 2 and the left plank, and I'm going to click R on my keyboard, and there we go. We can see both at the same time. We still have this problem with intersections that we need to fix. So let's go back to this, P on my keyboard, and let's see where the problem lies. Maximum, maybe maximum to the minimum. Oh, Okay, so I know that it's a Y, so minimum. Okay, that is working. X, maybe maximum. None. Minimum to minimum. Center to the maximum. Oh, I know where the problem is. So we need to go into the bounding box, which is this pin, which is basically going to look for a reference bounding box. We need to plug this here. Completely forgot to do that. Okay, and now we have it. I'm gonna go back to the match size node, and these are the settings that give me the results. Simple mistake to overlook, but as we work in Houdini, these are easy things to overlook. I'm gonna take out the reference flag from this. Okay, the next thing that we need to do, well, we need a duplicate of this plank and move it up a few times. So if you see this reference, we have 1, 2. Okay, let's take a pin out of this one, tab on my keyboard, and we can say copy and transform. I'm gonna display this node. Actually, I can merge it maybe together with this one so we can see the end result of all of that. I'm gonna select this node, be on my keyboard, and what we can do now is in Y direction, so XY, we can translate this until we are happy with the result. Maybe let's create one more. So what if we put one here? Nope. I want an even spread, so it looks somewhere along the lines where I like it to be. And if I go to the match size node here, I can actually use an offset to kind of make it a little bit different. Something like this, perhaps. Even I can go to... No, I can go to that one. So let's see. Let's try something that I like. Maybe something like this. Okay, yes. You can do it however you want. It doesn't really matter how we do it. So as long as it looks something similar to this one. Obviously we have two beams going horizontally, but I think for the effect, I'll go with 3. I think that's going to make it visually more interesting. We can always take it out, we can say, well, I want to, and then we can then spread it like this. But for the visual sake, I'll do 3. All right, we have gotten somewhere, okay? We have created this part, right? That we talked at the beginning of the video. Now what we need to do is we need to take this part and we need to duplicate here and then here. So we have this frame created. Well, what we can do is work with another match size node. So I'm gonna take the bounding box of what we have created so far, type in match size, put a display flag to it, press P on my keyboard. And what we need to do is we need an input of geometry to move and resize, which is from the merge. We need to resize the whole thing. And on the second input, geometry whose bounding box is to be matched. So both things. Okay. Create the spin. I'm getting rid of it. Now I need to create a copy of this, and I'm gonna justify this in X, I think. So minimum to maximum. All right, here we have it, but we don't really see a result. Why is that? Well, the match size node doesn't really give us a result. It just does a transformation. For us to get to the result, we need another merge node so we can display our newly created transformation with the previous one. And if we do that, voila, we have the second duplication of this effect. Great. Let's press W on our keyboard where our mouse is on our viewport and check for intersections and see how flush it is. There are no intersections. It is perfectly created geometry. Great. This is absolutely fantastic beginning, but we're far from completing this. There's still more sections for us to create. So we have 1, 2, I need a few more. So let's repeat those steps. I'm gonna take this pin, drag out from it, press tab on my keyboard, and you know what I'm going to choose. You're smart, match size node. First input goes into the merge because we want to move the whole piece, and we need a reference point to move. And I think it can be the same one. Let's try. Okay. We're going to justify maximum to the minimum, or actually minimum to maximum. Let's see. Nope. Actually, I can use this node. I'm going to copy it by pressing Ctrl-C and Ctrl-V. And you see that gives me the wires I don't really need. So I'm going to press Y on my keyboard, and that's going to give me scissors. And I can use left click on my mouse to drag over it. And there you go, I have cut any connections. So I'm going to take this pin, plug it over here, take this, plug it over there, and it automatically, if I duplicate the merge node again, okay, so let's see what we have. I need to connect the end result here. Okay, now we have more duplications, right? Exactly what we need. And let's look at the reference here. So we have 1, 2, 3, 4, 5 vertical beams. And we have 1, 2, 3, 4. There's one missing. Well, what do we need to do now? Well, we can't run through this whole procedure once again because that's going to take this whole piece, this whole piece, and it's going to duplicate over, and we're going to be left with the same, open panels. So what we need to do instead is we need to take this plank alone, and we need to duplicate it alone to this thing. How we can do that? Very simple. We already know the workflow. We take out our very convenient match size node. We know that we need to move this piece. So let's zoom into our match size node. Okay, this is not gonna. Okay, so we're gonna take the first input and we're going to connect it with this plank. And we're going to do it from the match size node because we need it flush to the ground. Okay, so I'm gonna put that into the first input of the match size node. And in the second, we want this to match the bounding box of the whole structure we have created. So I'm gonna bring the second input of that match size node into the merge node. And I'm going to bring out another merge so we can merge the result of what we have just done, put a display flag to it, and we see that we don't really have the desired effect. Why is that? Well, it is because we haven't really dialed in settings yet for this match size node. So I'm gonna go into the settings, and I know that I want to take and reorient this in the X axis. So let's try with the settings. So we're going to use maximum. And if I see this, I don't want this to kind of intersect with this one. So it's going to be justify X max to the minimum. Nope, to the maximum. To the center, to the same. Let's see. Hang on. Okay, so we take none, minimum to maximum. Let's see. Okay. And that worked. So we need to justify minimum to the maximum. All right, great. What else do we need? Well, as you can see, we don't really have the endings for this structure. And if you look into here, we can see that we have the tops. So what we actually need to do now is we need to create another beam. How we can do that? Well, we have already created beam here and here. So if I put the display flag to this one, this is the vertical beam. Another one is the horizontal beam. And I think we can use this for closing the tops. So I'm going to press Ctrl-C on my keyboard, open, mouse it to an empty place, Ctrl-V, and that's going to give me a copy of this box node. To help engage the proper size, what I want to do is put a display flag to the end result so I can see the whole structure in one piece. And I'm going to go back up at the top where I have just created this little plank. And I want to now massaging the settings for this. So let's try finding something that works for us. Okay, something like this maybe. Okay, I'm gonna put it to 3 perhaps for now. And what I want to do next is I want to align this piece here to this plank over here. Okay, the same procedure. So I'm gonna drag from this input, type in match size, bring it out. First input goes into the box, and the second output is whose bounding box we want to match. Well, we know that we want to match the bounding box of this beam, right? And we know that it's this, right? I mean, technically it's this, but with the match size node, flush to ground, it's this. So I'll take this and I plug it into the match size node, and now we might have what we need. If we dial in the settings, press P on my keyboard to get into the settings, and I think that's going to be an x-axis. So I'm going to try to put minimum to maximum perhaps, and I can't really gauge what I'm doing unless I see everything all at once again. So I'm going to drop down a merge node here, let go of the mouse, and we're gonna drag from merge. Actually, I need to zoom in for you to see. So there's the end4 network, which is a merge node. Put it inside of another merge, or actually, I don't need to use another merge. I already have the merge, so I'm gonna merge that match size node into the merge. So display the end result, and now we have it. Oops, Control Edge on my keyboard to recenter everything. So now I can play around with this match size node and get it up at the top. So let's see which combination of settings is going to give us that. I think we need to play around with justify y. So minimum. Let's try maximum to minimum. Okay, so that gives me the bottom piece, which is actually fine. A simple accident. It doesn't matter which part we create first, top or the bottom. You know, we can create the bottom right now. So that is created. Now we can go back to this box node and massage in the height or the width of it. So let's see. Actually, we're not done yet. I'm gonna go back to the match size node, and I want to reel it into the X direction as well. So let's try minimum. Okay, now we have it. Okay, so put it to the minimum. And now we have this nasty little thing that we don't really need. This part right here. So how we can get rid of it? Well, there's multiple ways how we can get rid of it. But without overcomplicating it, we can go back into the box node and try to play around with this setting. It might be this one. Nope, it's this one. Okay, so I'm going to reel it back in until I don't see it stick out. All right, perfect. Now we're perfect. Okay, we have created the top. What else do we need? Well, there's still top to be dealt with. So let's do that. I can take the bottom piece that we just created here, and I can duplicate that to the top with a match size node. I'm going to bring out the match size node, press P on my keyboard, and the question is, what do we need to connect now to move this piece back to the top? Well, I'm going to take the box that we just created, and I'm going to take the second input, and I need to use, I think it was this merge node. Okay, let's try. I'm going to take the second output of the match size node and use the merge node there. I'm going to select this while the display flag is on the merge, press P on my keyboard to see the settings for the match size node, and I think we need to play around with the justify y setting. So let's try. Okay, minimum, maximum. Okay, and I think this needs to be to minimum or maybe to the maximum. Let's see, maybe minimum. Okay, minimum to the maximum. All right, and now we have it, but there's a little bit of an issue for us. It's really not flush to this part right here. and it sticks out a little bit there. What we can do in this kind of scenarios is there's a offset by slider that we can actually try to use to, actually it's going to be, I think, X direction, yep, to try to reel it back a little bit like so. And if we do that and display everything like this, and let's not forget to take this little pin and put it inside the merge. So that's what we have created, okay? I know it looks kind of like a spaghetti, but all we're doing is using 3 nodes. We're using a cube node to get us the form of a plank. Then we're using a match size node for Houdini to help us with aligning and centering all our pieces. And we're using merge node to see the end result of all that. Super simple. And we have created the frame of this wall. Great. What I propose next, since it's a lot of things to look at, spaghetti, we don't really need to go back to this because I would say we're kind of done here. So what we can do is drag or encompass all of the nodes that we see on display that we just worked with, and we can create a subnet from it. And if I mouse over here at the top, which says subnet, and maybe you don't see it, maybe you see it like this, there's a little arrow at the top that allows us to expand the top menu. And with our node selected, if I click on the subnet, what it's going to do is, you can see it by the icon, it's going to take all of those nodes we just worked with and it's going to put us in a box. So we don't have to look at what's inside all of the time because we're done here. And whenever we want to work with it, we can select the node, press I on our keyboard, and there we go. We can access our work. I'm going to press U on my keyboard to go up a level. And let's continue our work. Well, I propose the next thing that we create is those planks. You see those planks coming horizontally? This plank, all the way to the bottom. Okay, so there's a handful of planks that we need to create. And we need to align it with our frame. So that's the next task on our hands. So I'm gonna work with this subnet now that we just used. All right, what I'm going to do is press tab on my keyboard. I'm going to type in cube, which we're already quite a bit familiar. I'm going to put a display flag to it by pressing down R on my keyboard while pressing P to get my settings for it. I'm going to press E on my keyboard and I'm going to select the subnet. And what's that going to give me is the reference so I can see this wall as a wireframe. And why I need to do this is because now I want to massage in this little box and form it into a plank, and I want to align it here, here, here until it reaches the top, just as we saw in the image, right? All those planks. So cube is going to give me a good starting point for that. So I'm going to select the box and let's massage this. The first thing that I see is not how I want it. I think we're not in the center. Okay, we're not in the center. We are in the center for our cube, but we're not in the center for our frame. An easy fix, we take our subnet, tab on our keyboard, match size. Let's use a match size node. That's going to help us recenter it. I'm going to justify it to the minimum. Take out the reference flag for that. And there we go. We're back into the zeros, which is very important for our work later. So the RBD bullet solver and the simulation can really process our geometry correctly without spitting us out any errors or unwanted defects. All right, so we have figured out how we can recenter this and make it flush with the ground. Let's put a display flag to the subnet and massage in, create a plank, okay? Let's see. I'm gonna work with these numbers. Something like this. Control H whenever you want to recenter it and get a better view of your plank. So maybe a little bit smaller. Maybe something like this. Let's see. Okay, I think this is a good starting point. Okay, next thing we need to do, as we can see, this plank is not aligned with our frame. So we can bring out a match size node and see if we can fix that. The first input goes here, and second input goes to the bounding box that we want to use. So it's that, and we know that simultaneously to gauge our results, we need the merge node to actually see the effect of the match size nodes. So I'm gonna display the merge node so I can see the end result of what I'm working here, and I'm gonna take out the reference flag for this one. Let's see. Now we see that our plank is somewhere in the center, which is already something, but not quite that we need. So we need to reel this in so it's in line with this frame over here. Okay. We need it here, not in the middle. So let's see which of the settings is going to give us that. Maybe Z. Okay, maximum to minimum, or minimum to maximum. Let's check. Okay, minimum to maximum. And our plank is aligned with the frame, but there's another problem. It is right in the center. We need it somewhere there or somewhere at the top. So it's aligned perfectly there. And I think that's going to be a y-axis. So let's try minimum there. To the same. Nope. Minimum to maximum. Maybe minimum to minimum. Let's see. So minimum. Yeah. That is perfect. So minimum to minimum. And I can actually use... yeah, I need Z as well. So we have our plank, but we have a problem. We have it stick out a little bit on the sides. A quick fix for that is going back to our box node, see? And we need to play around with the settings here. Let's see which one. Okay, so it's the first setting on the x-axis. I'm gonna zoom in so I have a better view until it disappears. Okay, great. And we don't have to be perfect, guys. I mean, this is a plan. In real world, rarely anything is perfect. I mean, if you're gonna cut it with a saw, I mean, you're not gonna get it perfect either. I mean, there's gonna be millimeters or centimeters that are off. So we have our first plank. Okay, great. What we can do now actually is we can give this a little bit of color, so it's something nicer to look at. I'm gonna go to the subnet and I'm gonna drag in between the connection there. Press tab on my keyboard and I'm gonna bring out a node called color. Now when you type in color, here's the node. I'm gonna click on it and see it's gonna make this connection with this wire. I can click once and it's going to give, basically it's going to seat the node in between that. So now we can, actually I'm gonna go to the merge and I'm gonna, with the color selected, I'm going to give it maybe a different color, something like a wood frame might have. It doesn't matter, you can create your own colors, how you want it to look like. I think I'm gonna stick with something like this, like maybe a fresh wood or some dry fresh wood. And I want to do the same for these planks, right? I mean, if you look at the original reference, they're kind of darker, not gray. So I'm gonna go to this node, same thing, in between the connections, I'm gonna type in color. I'm gonna drop down the color node. With it selected, P on my keyboard to get my settings back. And I'm gonna choose a color that resembles a little bit more of blank. Maybe something like this, but not as saturated. So let's see where we can change the saturation. I think it's here. Okay, and maybe a little bit bring down the value, which is darkness. Maybe something like this. And I'm pretty happy with the colors, guys. Okay, there we go. So where are we? We have created the plank, we have created the frame, we've got our colors. What if we try to give this plank a little bit of a bevel? Because right now we have these edges that are super sharp, right? If we look at it, doesn't really give us any highlights or anything. I mean, if we look here, obviously, I think it might have a little bit of bending, but that might be faked with normals or weighted normals. But what I want to do is I want to take our pieces and I'm going to select this in between the connections between my box and the color node, tab on my keyboard, and I'm going to type in, not divide, but what was the node called? No, that wasn't extrude. No, it was extrude. Let's try, no, it wasn't extrude. Let me think. Extrude. This is where I need help. Hang on. I'm gonna go into the node that I just created previously on my network. Okay, we need to bevel it. In 3ds Max it's called chamfer, in Maya it's called bevel. That's why I get sometimes confused. So we take out poly bevel, put it in between, and I'm going to select that, and I will check how much of a bevel I want to add. So I'm going to use this slider, and if I middle click on my mouse wheel, use this unit, just by dragging my mouse up and down without going out of the bounds, I'm going to slowly add a little bit of bevel until I'm happy with this. Okay, maybe something like this. Okay, let's look at the end result, how it looks. And it looks kind of weird because the reflection is supposed to kick in, and right now it looks like the normals are kind of wrong, you know. And the next thing we need to do is right after the poly bevel node, we need to add a normals node because we need to sort out the normals. And when I do that, okay, let's see, cusp angle. And let's see if that solved my problem. Yes, it definitely did. Okay, and if I actually check my previous network real quick, so stay where you are. I'm gonna check my network real quick. So I created a box, created a poly bevel, then I added normals. And what settings did I use? Actually, I'm gonna take this node, I'm gonna copy it, and I'm gonna paste it here, split any connections. I'm gonna select mine, click Alt E on my keyboard to get rid of it, or alternatively, if you don't have that keyboard shortcut set, you can cut it like that. And I'm gonna take this and I'm gonna put it in, and these are the settings I used. Okay, so cusp angle was zeros, and that is that. Okay, we have that. Let's put display flag back to our merge. And now what I want to do is I want to copy and transform this plank all the way to the top. So how can we do that? Well, I propose we bring out a node called copy and transform. And if I type that in, well, we have this node. I'm gonna click that and I'm going to try to use it here. Select it, P on my keyboard, and I think we need at least, I'm gonna start with 10 copies, okay? We're not gonna see anything at the moment until we try to use a translate setting. So let's try to put it not an X, but I'll try to use a Y direction. See, when I do that, we see our planks here. And I'm gonna dabble with the settings a little bit until I find something that I'm happy with. Right now, I'm trying to gauge the separation between pieces, and this slider helps me do that. And see if I increase the total number of planks, I have that, and it's a little bit too much for my taste. I'm gonna try to tone it down a little bit, something like that maybe. Maybe a little bit more to kind of, let's see, maybe a little bit down, something like this. Okay, I think I'm happy with this. I mean, we can see this kind of sticking out. I mean, maybe it's not visually perfect, but I mean, it looks really good to me for a starting point. Okay, what else? Well, what I need to do now, I'm going to select this stream, press A and drag. So what I did just there. So select these nodes, hold down A, and while at it, left mouse button, you click it and pull up. And that's going to help me align my nodes. And what I can start to do is kind of organize my scene a little bit, because if I want to ever refer back to it, it's easier to read what I have done. So I'm going to select these nodes, and I'm going to create a network box. And network box is basically an organization tool that helps me organize my scene. And what else I can do is select this network box, press C while my mouse is here, and I can change colors for it. Usually I like black, but you can choose whatever color you want. I'll use black because it helps me the colors stick out a little bit. I mean, the notes read a little bit better. I'll take a sip of water. All right, let's continue our work. I'm gonna select this node and do the same thing here. All right, what we need to do next is, if I kind of go back to this place, we can see that, I mean, this kind of sticks out. I mean, there we have the planks, here we don't have. I mean, this step is going to be optional, but we could, in theory, duplicate these planks that we just duplicated vertically over to this side. Is it something you want to do? Up to you. But let's try and see if we can do that. And if we don't, we can always leave it as is. How we can do that? Well, we just created this row, vertical row of planks, and I think we could use a match size node to make it happen. And I need an end result of these planks, which comes out of this copy and transform node, right? So this is the end result. If I display it, we have all of them. So I'm gonna use geometry that I want to move and transform, plug it there. And I need a bounding box, okay? I need Houdini to tell, please align with something. And I want to align it with my frame, right? Which is this. The match size node is the end output of what our work there. So I'm gonna take the second input of the match size node and tell Houdini that I want to reference to this frame. And I'm gonna plug it into this match size node, display it, and nothing really happens until we see there's an intersection that we definitely don't want. So we need to fix that. P on my keyboard with the newly created match size node. And I want to try and justify it in Z. So I think we can use minimum to maximum. And that doesn't give us the result we want. So let's try maximum to a minimum. And that is exactly what we need. And if I press W on my keyboard and inspect for any intersections, you're not going to find them, because everything has been mathematically aligned to each other. And we can say that we have created our frame that we had in our mind at the beginning, except we don't have the destruction created just yet, and we're getting there. But what we have created so far is already a big leap, and I want to congratulate you for your patience, for sticking around this long. You now know how these walls are created inside of Houdini. But this is not going to really work if you want to feed these things inside of an RBD bullet solver. So what we now need is a way to split this geometry apart. I propose we take a frame and kind of make an output of it completely separate from the planks, so we can process the geometry independently. Well, how that's done is usually we take a match size node output, press tab on my keyboard, and I'm going to type in null. I'm going to press a display flag to it, and I'm going to name it frame space out. So I know that this is an outcome, and this is how I can separate it and work later on with this geometry. And I want to do the same thing for this match size node, right? Which actually is this one, okay? And we don't really need to use this here. We can get rid of that connection because we just want to specify an output of this. All right, I'm gonna use another null at the end of the network. And nulls are just, this node doesn't do anything really. It does what you want to do. And for me personally, I usually take this node out for two reasons. First is to mark an end of my network, or when I want to visualize things like constraints or attributes. So I'm going to connect my match size node with the null, and this needs to go actually in here. Okay, and I'm gonna name it planks out, and there we have successfully split our geometry into two pieces. So we have our frame and we have our planks, and now we can work on each of them separately. Okay, I'm gonna go to the file and save my scene, so whenever I want to bring it back, or God forbid Houdini doesn't crash, I can always retrieve my files. It's always good to save our work frequently, so we don't have to redo all this. I mean, it's time lost. Okay, what next do we need to do? Well, I propose that we start to fracture our geometry. And I want to start with our frame. So I'm gonna, actually, you can comment out these boxes. So I'm gonna call this a frame, so it's easier for me to reference this back. And this is going to be my planks. Not a plan, but planks. Okay, planks. So our frame. What I want to do next is I want to think about how I'm going to break this into multiple pieces, because right now it's like a one and the same geometry. Okay, there's nothing that cuts it. Okay, there's nothing that cuts it. So we need to use a node called RBD material fracture node. And if I press tab on my keyboard, type in RBD material fracture, there it is. I'm going to use that node to fracture this frame. And if I pull up settings for this node by pressing P on my keyboard, what I can do is fracture this geometry based on a material type. Look, there's a material type setting up at the top, which is currently set at concrete. Now we're working with a wood material, so it would make sense to change concrete back to wood. So let me do that. Houdini is going to take some time to figure out how to make that for us, and it's going to take a few seconds because it's kind of heavy on our PCs. Now this looks something like a wood would look, and if I go after and add a exploded view node after the RBD material fracture node, set my display flag to it, and bring down this uniform scale setting, we can see that our frame has been split into these cool looking wooden chunks. So let's play around and make this a little bit better. I think what we can do is go into the cluster setting, and if you can't see it visualized here, it's probably because of this setting, so you have to, tick it. All right, so size, I want to increase the size to maybe like 3, 3, and 3. Or actually, let's try 3 in the y direction. All right. And for me, I think this looks much better because I don't want this frame to fracture into a million smithereens. I want to keep the structure, but I want the structure to have also some kind of like split, and I think this setting is going to give me what I need. You're free to experiment with your settings, but I'll keep it as is. So what else do we need from this RBD material fractured node? Well, if we go into the constraints, remember I said I'm using a null node. You don't need to follow what I'm doing. I'll just want to show you this setting that you can visualize constraints. And constraints are basically a relationship between each fractured piece. So we have this piece, and this pink piece. And what basically this constraint network does, it basically establishes a relationship each of these pieces is going to have between each other. So we need constraints, grain, enable cut. Okay, so I'm going to leave everything as default, and I'm going to experiment with this fracture. Oh, no, actually, I'm not going to use that. I'm going to use that setting for the planks. So let's switch to the planks for a second. I'm going to drop down an RBD material fracture node, the same as we worked. And I'm going to plug in the end of my planks, which is a null, into the first pin, which takes in geometry. Put the display flag to it, and press P on my keyboard, and you know where this is going, right? Material type is currently set to concrete. We need to set it to wood. So I'm going to click that, and I'm going to give Houdini a few seconds to think about. All right. Let Houdini do its thing. Might take a while depending on the system you're working with. And this is going to give us a very realistic wooden fracture. And it's worth going through this step because it's going to either make or break the look of our destruction once we start to simulating it. Alright, so there we go. We have a material type set to wood, and we're doing the fracture per piece, so make sure that is ticked there. Okay, great. This is somewhat realistic fracture, I would say. And I think we can move to the next step. So we have our frame fractured, we have our planks fractured. So what's the next step? Well, we need to do what is called packing, because we need to kind of combine these streams. Remember, previously we talked about each of these material fractures give us also the constraint network, right? So we need to combine these, and it is done by RBD pack node. So we're going to choose RBD pack, drop it down, and we're going to use it for each of our geometries. So I'm going to take our geometry, I'm going to take constraints, I'm going to also take a proxy geometry and plug this inside the RBD pack node. And while I'm in here, I'm going to copy it by Ctrl-C on my keyboard, paste it over here, and I'm going to do the same thing for our planks. All these three go in, and now what we can do is we can take this and merge it together. Now, if I take my merge node, which we have used a bunch of times up until this point, now all I have now is my geometry plus all the proxy geometry plus all of the constraints coming into here. But we're not done yet with this part of the setup. What we need to do now is we need to use the same node, but for unpacking or RBD stuff. So basically we're joining together all of these streams, and now we need to split it once again. So I'm gonna connect the merge node with RBD unpack, set a display flag to it, and now what we can do is we can start putting this into the solver, or not the solver, but the constraints. We can start creating constraints. So what I propose we do now is bring out a node called constraints, constraint properties, okay, and I'm gonna plug my geometry, my constraints, and my proxy geometry in it, set a display flag to it, and press P on my keyboard. And what we need to do here is I want my geometry to switch between glue constraints, which are sort of like very rigid and break only when a certain threshold is broken. For example, this strength right here, which is set as 1000 at the moment. So the first constraint I want is glue, but then once the glue, the first constraint I want is glue, and then I want to switch to the soft constraints. All right, or actually vice versa. I'm going to use soft, and then maybe actually let's do this. Actually, I'm not going to use this, but I'm going to use RBD configure node instead. And we may want to jump back to that node later down the stage. So RBD configure node. And this node is going to help us basically, if I'm going to simulate this at the stage we're in, what's going to happen is the geometry is going to basically collapse on itself. And if I bring out RBD solver, the brains where we feed all of our data in, which is going to help us simulate the whole thing, is I take my geometry, my proxy, and my constraint geometry, feed it into the RBD bullet solver, and press play and see what's going to happen. See? The geometry keeps going and going down, and it's not something we want. What we want is our geometry to stay put. How we can do that? Well, there's a handy tool inside of this RBD solver node, and under collision there's a ground collision option that we can use. And if I specify that to ground plane, and now when we simulate our geometry, you can see that destruction start to happen. But is it something that we want? Definitely not. I mean, we're going for a way different result. So that's why I brought out RBD configure node just a moment ago. We need some way to kind of base this geometry so it doesn't fall over as we hit simulate. And it's going to be done by an attribute, or basically a method called a bounding box that's integrated into RBD configure node. See, there's a bounds option, which is currently set to bounding geometry, which is actually this pin right here, static bounds. And we can create our custom bounds. And I guess it's easier shown than explained with words. So we're going to use a good old box geometry. I'm going to set a display flag to RBD configure node and press display flag to this node. And I'm going to P on my keyboard. And then with my mouse over the viewport, I can press enter on my keyboard. And what I want to do is I want to create some kind of a bound on these sides so that I can feed that into the RBD configure node and say I want these pieces to be inactive. I don't want them to move no matter what. And this is going to help us do that. So I create that for the right side, but I want that on the left side as well. So I'm going to copy this node, mouse over here, paste that, and I want to negate that value. And I think it's this one. So I'm going to press or type in minus, and that's going to give me an opposite direction. But now I want to kind of merge them together and put them both inside of this RBD configure node. So I'm going to use a merge node, take the end result of the merge node and put it into the static bounds geometry. And if I select this RBD configure node, press P on my keyboard once again, make sure that the bounding type is set to bounding geometry. I'm gonna pull this up a little bit. I'm gonna press activate or tick activate. And one means it is active and 0 means it is not active, and which is 0. And we want to tick use bounds that we just generated. And with this setup, we're saying please use, please use this geometry as a means to deactivate the side pieces of our wall by setting 0 and use bounds. I hope that makes sense. Oops. Here, 0. Actually, I'm gonna delete channel references. Let's see. Okay, so 0. Everything is good. Okay, I'm gonna click that. I'm gonna initiate the RBD bullet solver. And that's gonna take some while, so I'm gonna press cancel on it. And I want to make sure I'm on the first frame there. Okay. Let's simulate and see what happens. Okay. Just few of the pieces collapse on themselves, and I think that could be the reason that our constraints are not strong enough. And those are located usually here. So that is a frame, an RBD material fractal planks. Okay. And under constraints, we can set the grain strength, cut strength, search radius. Actually, I want to check if that is actually true. So I'm going to go into this geometry once again, which are the bounds. And what I want to do is maybe pull them a little bit closer to the center and see if that's going to solve the problem for us. Okay, so I'm going to use this, and same for the left side there. And we're dealing with a lot of computational power, so everything is going to take a little bit of time here, but we have time. So I'm going to put this a little bit closer to the center, and I'm going to replay this once more. Okay, this solves the problem, and as you can see, we're troubleshooting and we're fixing stuff in real time, and this is the workflow everyone goes through. And you see these tutorials online that make everything look so easy. That's not really the case. The real case, how we work here, is just like that, and just how you saw. So okay, we have everything set up, but what we want to do now is, wouldn't it be nice if we specified a place where the destruction can happen, sort of like limit or mask out areas where the destruction can happen and where it cannot happen? Because if we look at this example here, I mean, we have a hole right there, but obviously we could make holes there as well. But for this tutorial, what I want to do is I want some way to limit this. And the way I can do this, I can once again copy the RBD configure node, and similarly how we created the bounds for the sides, I can create bounds on the interior. So I'm gonna kind of juggle this in, and what I can do now is use the same bounding box, and this time I'm gonna use a node called sphere, and sphere is going to help me create this area. Press P on my keyboard to pull up settings for this node, I'm going to increase the radius a little bit, something like this. And watch this. If I select my RBD configure node, what I can do next is set this to active instead. So what I'm saying is everything that encompasses inside of this sphere, I want that to be active. Everything else is going to be inactive. And the way we can visualize this is by going under the visualize setting, set active, and see, there we have it. This is going to be destructible. And if I really want, I can kind of increase maybe this a little bit. Maybe put it something like, let's see, something like this. Okay, yes. Maybe this a little bit higher. I think this looks pretty good. Okay. We have created active and deactivated settings within this geometry. What else we can do is I think we have come to the stage where we can really start to test this out. So I propose we create a collision geometry, or some force that is going to hit this wall and is going to trigger a destruction. And there's multiple ways how we can do this. And I propose we create a simple sphere geometry that is going to go through this wall. So I'm going to put a reference flag to this node, press enter while my mouse is over the viewport, and I'm going to kind of put it somewhere around here maybe, so it can really go into this wall. And I think it's a little bit too big, so I'm gonna scale it down a little bit, something like this. Looks nice. Okay, and maybe a little bit closer here. What else I can do is actually animate this. I need this not to be static, but I want this to kind of shoot in the direction of this wall. So I'm gonna pull out a node called translate, if I can spell it out correctly, transform node. And this node is going to allow me to animate my stuff. I'm gonna press P on my keyboard to pull up the node settings. And I'll make sure that I'm on my first frame, okay, in this timeline. And what I will do is actually, hang on. Okay, what I want to do next is navigate to the Z coordinate, press Alt, click on it, and it turns green, which means we have created a keyframe. Then what I want to do is click on this time frame and drag until I see 24, so which means a second has passed, and I want to animate this geometry in the direction that it shoots through this piece of wall. All right, so 9 units. And now this is like in this muddish, greenish sort of tone, which means a change has been made, but it hasn't been set. And as soon as we click Alt, left click on our mouse, sure enough, we create another keyframe, and if we scrub through, we have created an animation. And if I play it back, there we go, we have an animation. And we can use this animation to feed it into our RBD solver and see how it destroys our piece of wall. So what we need to do next is we're going to take an output pin of the transform node, and we're going to feed it into the fourth input pin of the RBD bullet solver. And if I try to play it back, I don't think anything is going to happen. And that usually is because the RBD bullet solver collision type is set to animated under this collision type. And I think we need a deforming. And if I click deforming, that should initiate destruction. So let's see if that is true. Okay, yes. We can see that sure enough, there's something happening, but it's not really giving us the results that we aim for. Well, why is that? Well, I think that could be because our sphere is too narrow. And I propose we make it a little bit bigger, something like this. And we can actually scale it using our parameters here. So something like this. We go back to the RBD bullet solver. And once again, play it back and see how that looks. Okay, this is looking a little bit better. But I'm not really sure that if I like what I see. So, what can we do? Well, let's do this. I'm going to, inside my frame, RBD material fracture node, I'm going to press P on my keyboard, and maybe we can go under the constraints, and we can put our grain string to something like 10,000. 1, 2, 3. So 10,000. Play back our animation and see if that solves the problem. A little bit, maybe another 0. Okay, that doesn't do much, so I'm gonna put it where it was. I think it was 5,000. So let's troubleshoot this. Maybe the problem is... what if we get rid of the constraints? So I'm gonna delete the constraints on our frame, and let's see if that solves the problem. A little bit. Let's check the RBD enable constraints. Well, I think what we can do is... Actually, what I want to do next is let's create a constraint that's going to kind of... So at the moment, we have 2 layers of constraints. We have layers for our frame. We have layers, constraints for our planks. So if I visualize that with a null real quick. So we have an RBD material fracture. We have constraints for our frame. And we also have constraints for our RBD material fracture, okay? And those both go into the RBD bullet solver, but we don't really have constraints that kind of hold everything, all of our pieces together. So I propose we create a 3rd layer of our constraints. And that is done by merging our geometries together. So what we can do is type merge and bring out our merge node. Then what we want to do is merge together our planks with the merge node together with our planks. So frame with the planks. So we'll take our frame from RBD material fracture node. Then we're going to take our mesh from RBD material fracture, which is planks. And if I kind of display the outcome, we should be here. And what I can do now is I can create my own custom constraints that is going to kind of hold my wall together. And what I can do then is merge the constraints that hold everything together with the constraints that are on the planks and the ones that are on the frame. So let's see how this pans out. I'm going to type in connect, and I'm going to look for a node called connect adjacent pieces. So I'm going to drop that down, put my display flag to it, press P on my keyboard, and I want to see which of these options is going to give me the best result. Let's see. Adjacent piece. This could be quite heavy. Maybe we can use connect adjacent points. Maybe this one, okay? Then what we need to do, we need to tag these constraints. Now we have created, but we haven't really told Houdini what they're supposed to be. And I want these to be perhaps soft constraints. So I'm going to type in constraint properties. Constraint properties. And I want to take this output pin from connect adjacent pieces and plug this into this pinkish one. Okay, press P on my keyboard. And I want to set them to soft at the moment. Okay, so now I have tagged this geometry as soft constraints, or should I say constraint network. And for maybe simplicity's sake, we can plug this in as well. So both of them come in here. Well, next what I want to do is I want to connect or merge these constraints that hold all of the wall together with the ones that come out of RBD configure here. See? So we have this, and I want to combine them with this. So I'm going to type in merge, which is going to allow me to do that. So I'm going to get rid of the null, and I'm going to try to, I'm going to actually make, hold down Alt on my keyboard, and I'm going to press on this net line, which is going to allow me to create these pins, and I'm creating them to get the merge node in, like this, and I'm going to drag this into the constraint properties node. And if we have done everything right, what we should see is that everything holds together a tiny bit better. And before I actually do that, I want to go into the RBD bullet solver and check that it reads in both soft constraints and glue constraints. So because we have both now. And distance threshold, I want this to switch to the next constraint. And I'm going to make this a little bit lower. So basically this is going to be a rule that governs when constraints switch to the next one. So let's see how this looks. Okay. Actually, I want to move here. Let's see. Okay, it looks like something, but still not something that we want to see. So let's see. Let's go to the adjacent pieces. Maybe this RBD constraint properties and stiffness. Maybe it's too stiff. Maybe I need to lower the stiffness. Play it back. Still, it's too fast, and I think maybe our geometry is going way too fast. So we need to reel this a little bit. So I'm gonna take this keyframe, I'm gonna select it, I'm gonna drag it a little bit out. Okay, and that solves the problem a little bit better. Okay, let's check. Okay, so this is starting to look a little bit better. Now, what else do we need? So this says we don't have a name attribute. Maybe we can add a name attribute here, and that's going to solve that. Put it here. And let's see. Okay, we can actually make it add a name attribute here. Okay, the next question is, what don't we like about this destruction at the moment? We need to analyze the key areas that we want to improve. Personally, I would like the destruction to be a little bit spread out. So we need to go back into the RBD configure output, and I think, RBD configure of the sphere. And I want to make sure that it's kind of looks weird. So I need to reel this back a little bit, I think. Something like this, maybe. Maybe a little bit more. Okay, and it's still not giving what I want, so maybe we need to decrease the strength of our pieces. So let's check RBD bullet solver and see our constraint rules, and I want this to break by angle as well, so a little bit more of an angle. Collision, constraints, advanced, glue, maybe a little bit lower the glue, and soft stiffness, maybe rest length to 0. Let's see. Okay, now we have a better result. Okay, we're almost there, I think. What I would like to do is I want the destruction to be a little bit more on these piles below. So I need to play around with this geometry. I think this is a problem area. So what I want to do is scale it up a bit, something like this perhaps, and see if that solves my problem. It kind of does, but I mean, we're having the same problem with the frames now. Well, what we can do is actually we can work on our frame a little bit. I can use a RPD configured node, but maybe I can use an RBD configured node and make sure that I set bounds for my frame as well, right? So there we are. I use this, and let's see if we can actually copy these and paste them here. I'm gonna see if this can solve my problem. And I want to set this as a bounding geometry, and I'm gonna set inactive. So these pieces are inactive. And if I go back to my RBD bullet solver, actually probably I wanted to start at the first frame, and let's see. Let's run this simulation again. All right. Still not really sold on, I'm not really sure why these are not exploding. I think it's still this one. We need to reel them in a little bit and center something like this maybe, or I need to. It's all about playing with the settings. There are no rules. I mean, this is dynamic. You have to solve the problem as we speak, basically. So I'm gonna set the position for that bounding geometry a little bit off, something like this, and let's see if that gives us a better result. So let's see. Okay, I mean, maybe it is a little bit better, but I don't like that this is shooting off. So maybe we can go into here. Let's see what this is. No constraint geometry, and I think it's giving us that because we need to put maybe a name here. Let's see. Okay, so that error message disappeared. Okay, so let's see. Maybe we can switch the constraints from soft to glue, and we're gonna decrease the strength a little bit, like this, and then we can play it back once again. Let's see. Okay. Let's try maybe 700. And oh, we need to decrease the stiffness for the soft ones, something to a 2. Press P on our keyboard. Let's see how that looks. Okay, this looks like something I like. So I'm going to pull this geometry up a bit because I want the destruction to happen a little bit up at the top. Still not what I want, so let's go into the RBD configure node and let's check. So we have the bounding geometry. Okay, I think there is a problem with this one. It is active, but it's not how I want it to be. So maybe we need to still, I'm gonna actually revert this back to the default. Where is it? Actually, default. And I'm gonna redo this. Okay. Polygonal mesh. Increase radius. I'm gonna go back to the RBD configure and see how that has changed the active planks. Okay, well, this is much better. Maybe too much, but actually it's too much. So let's go something like this, maybe. Okay, maybe something like that. P on my keyboard. Let's see if that looks better. Nope, still doesn't give us the results we want. So let's troubleshoot this. Actually, so the frame search radius. Maybe we can improve the search radius for the constraints a little bit. Definitely want these to be glue. Maybe we need to increase the grain strength a bit as well. So let's check about that. Okay, maybe we can set this to 10,000. Okay, RBD pack, RBD configure. And I want to uncheck these. And let's see if that has given us a better result. Actually, I'm gonna press and type in a null because I don't want to see all these things. So I'm gonna display just the null. Still nope. And where's the problem? So let's see. Maybe this is too hard. Maybe this needs to be something like 200. It's holding everything together way too strong. And now the pieces don't act really. I think I might have set the RBD material fracture. Let's reel this down to something like 2000. And let's display our animation. So it goes through here. Oh, okay. So we need this to be a little bit lower. So something like this, perhaps. Okay. Now I want to probably geometry. Maybe this is going to. Oh. Okay. Maybe glue needs to be something like 50. And we need to decrease the stiffness. Going to the RBD bullet solver. P on our keyboard. Constraints. Maybe we need to kind of make these a little bit smaller. And then we watch again. Still something is too high. Let's check. So maybe this to wood. I don't think that's going to change anything. This looks okay. Maybe this to something like 500 and this to 300. We have clusters. Maybe random detach. Okay, let's try and sim this again. Okay, this looks to be interesting, but we don't have... I wonder what if I disable this, and let's try again. Let's disable this part as well. It's all about playing around with the settings. There's no set rule that we need to follow. This is a custom simulation, and there's, as you can see, a lot of moving pieces, and we're shooting from one node to another node and trying to figure out what may solve the problem we're facing right now, which we want to make the destruction have a little bit more spread, a little bit more area to be affected by the ball that is colliding with the wall. So let's see. Up, so I'm looking console back. Go to this frame number 1. Let's see. So I have this name attribute, oblique constraint properties. Oh, okay. So this has to be something like 300. Okay, and I think I can play it back. Reset the sim and press play on the keyboard. And that should work. Okay, it does. And now it works. So as you saw, it's quite a bit of things to go through. You never know where the problem lies, but if you're patient enough and you double around with the settings, you can figure it out. So we're gonna let Solver to do its job, and then we're going to see this once more without these white lines, which are constraints. So I'm gonna stop the sim, put display flag to the null, and I'm gonna play this back and see what kind of result we have. Okay, this is not too bad. We definitely have gone a long way, but for me personally, I would say that destruction is still a little bit too much for my taste. I would like it to be a little bit kind of to the center. Again, how we can do that is we go into the RBD configure and we kind of enable these two guys and see if that gives us any better result. And we solve this destruction once again. Cross our fingers and hope that it is what we're looking for. Okay. Now I'm going to stop it for a second because at the moment I think it is way too restricted. So I'm going to go into my sphere. Actually, go into my sphere. I'm going to put a reference flag to this, P on my keyboard, and I think this could be set a little bit higher, as well as this. Oh, that is way too much, so we need to reel this back in. I think something like 2 might work. Actually, 2 is going to be too much, so 1.3 perhaps. And I'm going to put center to 2 to bring the ball a little bit up there. So now I am going to sim this again. All right, there we have it. We have a little bit a wider spread for the destruction. So you can see the destruction happens on a much bigger area now. So this is much better than we had previously. So if I stop this and play it, there we go. And basically, we could call it done, but what we can do is we can change the overall strength. So where is it? Houdini material. Houdini material fracture, connected pieces, merge. Actually, we can still still mess around with this ball a little bit. Maybe put it up at the top here. And maybe I want my ball to actually to be a little bit higher as well. So the destruction happens not in the center, but it happens a little bit higher to the top. So I'm gonna toggle my ball, make sure it's here, and I'm going to translate it up by a little bit, something like this, maybe a little bit more, something like this. Then I'm going to initiate my RBD bullet solver. And actually, I'll get rid of the constraints. I don't want to see them. Visualization, constraint geometry. So it's easier and cleaner to look at the scene. And let's play it back. And well, there you have it. Basically, I have given you the tools and the workflow, how you can achieve this kind of effect. And now it's really up to you to kind of massage in those settings and create higher like areas where you want destruction to happen, or maybe you want the ball to kind of go in a little bit faster, or you want the constraints to break easier, or you perhaps want more elasticity. But if you dabble around with this, and you can take hours to do so, you can create something that looks really nice. And again, to show you my result, and this too took a while to create this sim. You can create these destruction effects like this, following the same model that we laid out for us today. And I suggest you to dabble around with the settings. Don't be afraid to experiment, to move sliders around, and who knows, maybe you come up with a destruction effect that is much better than I have showed you today. Again, thank you so much for watching, and I'm going to see you in the next one. Bye.